should we start with this? Actually, I had started with Safia to electric potential. As she is coming, we'll start and then we'll continue with the electric potential. Okay. So, what is electricity? What is electricity? Rudra?
The flow of electrons.
Yeah, the flow of electrons. Yes, the flow of electrons is the electricity. Means in a definite in a and flow of electrons means it's not like flow of electrons only, because electrons, where there is a if this is a conductor, this is a conductor, if this is a conductor, and if there are free electrons, then it's obvious that they will flow, right? But they will flow in random order, means they will flow in a random order, means some in this direction and then this direction, they will flow randomly, haphazardly. Okay. But when the electricity pass through the wire, when the electricity, when we place battery in this, and when the electricity starts flowing, just wait. Good evening, Mariam. Sorry, Mariam, I'm saying Asafia because you messaged with the Mariam now. So, wait, I'm just logging with my mobile phone because, okay, is it getting shared? Okay, getting shared, right? Yeah, but I was telling, whenever we place battery, when we place the battery and start the and start the switch on. Okay, first it will be like this, and then if we'll switch off the switch on the light, switch it on, then what will happen, the key will close. Okay, the key will close, and what the symbol of getting key closed, it is like this. Okay, now the key is closed. Now the electrons starts flowing from negative to positive, right? Negative to positive, it means that it will start flowing in this direction. All the electrons will start flowing in this direction. Yeah, all the electrons will start flowing in this direction, and then electrons will start flowing in this direction, and the current will flow in opposite of the flow of electrons. Okay, and then we say that electricity is there because in a conductor conducts the electricity, but when the potential difference will be there, when some battery, when we'll place some battery and switch it on, and then we can say that there is electricity. Okay, flow of electrons in a from negative terminal to positive terminal. Electricity is an essential part of life in today's world. It is controllable and convenient form of energy because it has provided so much of convenience to us in every field, right? Without this, we cannot even imagine our life now. Now, electric charge and electric current. Electric charge and electric current. Okay. So, what is electric charge? Charges are positive, negative, and electrons, protons, and neutrons. Right? Neutron will be having no charge. It has no charge. Proton is having positive charge, and electron is having negative charge. What is the magnitude of charge? What is the magnitude of charge? Rudra, do you know what is the magnitude of an electron? How much does the charge contain? How much electron does it contains the charge?
I don't.
You don't have remembered?
No.
It's Safia. Safia, are you there?
Yes, ma'am.
Hmm. Can you tell me the charge in an electron?
It's 1.6 into 10 to the power minus 90.
What? Meter?
Coulomb.
Coulomb. Okay. Coulomb. Don't forget the unit. Okay. 1.6 into 10 power minus 19 coulomb is the charge in one electron. This is the whole charge in one electron. It will be in negative sign for electron, and it will be positive sign for proton, and neutron will be having no charge. As already you are knowing, in chemistry you must have read ki in the nucleus inside the electron, inside an atom, what is there inside the nucleus? Proton and neutron, right? And electrons revolves around the nucleus in a fixed orbit, right? Yeah, there'll be 2 electrons, and then in the another shell it will be 8 electrons, right? And then another shell it will be again 88 electrons and 18 electrons, so and so on, right? You must have read these things. So what is this? Proton and neutron will take no participation in inflow of electricity. The only the only thing that takes part in the flow of electricity is what? Is electron. Okay, because electron keeps on moving throughout the conductor, right? So electron is only responsible for the flow of electricity. So this, we are having charges and charges. What is that? Charge and current, right? Charge and electric current. So what is that? Key in this only we'll study quantization of charge. With what we denote the charge is Q. We denote the charge by Q. Okay, and the unit of charge is what? Unit of charge is coulomb, which is denoted by C. Means charge we denote it by Q, and coulomb we denote, and the unit of charge is coulomb, which we denote it as C. Coulomb, C. Okay, capital C. And for charge we can also write it small q. Also we can write it in this fashion. Okay, so now what will happen if there are one electron? If we talk about one electron, we talk about two electron, we talk about three electron, how many electrons are there, and so on. Ne. This is what we call as Q, quantization. This is what we call it as Q, quantization. Means this is the whole charge. Means how many charge does the matter is containing, how much charge is the thing containing. So how we'll say it's having one electron, it's having two electron, three electron, and so on. So how much it will be? It will be what? It will be what? Here it's one electron only, two electron only, and like this. When we talk about n number of electrons, then we say Ne, which we write it as Q. This is the packet of electron. This is what? This is the packet of charges, which we called it as Q. So Q is equal to Ne. Whatever the number of electrons will be, we'll write it here, and the charge of electron, we'll write it here, and then multiply them, and then we'll got to know about how much charge does the body is containing. Okay, does the body contain? Fine. So what we can say, it this is what? This is quantization of charge. Q, quantization of charge. Quantum means what? What I said, quantum means packet of charges. Quantization of charge. And we cannot say it like it will be having 1.5 electron. This can never be possible. Half electrons, no, we cannot write it as half electron. Half electrons does not exist. Okay, in any question it can be given in a way that q n will be in such a way that it will be not not a perfect number, but in question it can be there, but it will not be true. Fine, because n will be only the whole number. It must be a whole number. 1, 2, 3. It cannot be 3.5. No, it cannot be 3.5. Okay, it must be whole number. It must be whole number. 1 electron, 2 electron, 3 electron, like this. 100 electron, 1000 electron. Okay, whatever be the number of electron will be there, we'll multiply it. Suppose n will be 1000, given n as 1000, and then we have to know about the q. Then what we'll know? What we'll do? We'll apply this formula. Q is equal to Ne. This might not be given in your NCERT, but it comes in your exam. Okay, Q is equal to Ne. So what we'll do? We'll just put the value of n and put the value of charge of electron, which is 1.6 into 10 power minus 19, and we'll use this column. Okay, n will be having no unit because it will be because n will be having why it will be having no unit. Just we'll discuss it after this. So how much it will be? It will be just we can write it as 10 power 3. So we can add the powers. It will become 10 power minus 16 coulomb. This is what Q is equal to 1.6 10 power minus 16 coulomb. And why n is having no unit? Can you tell me? Can you tell me?
Because it denotes the number of electrons.
Number of electrons, and how can you prove that n will be having no unit? How can you prove this? Rudra, how can you prove this that n will be having no unit? See, q is equal to ne. From the formula, you can prove any of the unit with the formula. If you are not knowing about the unit, just write the formula and then figure out the unit. Just leave the n alone, and q will and n will be equal to what? Q upon e, right? It will be equal to q upon e. Fine. So what you will do, what you have to do, q is having charge what? Coulomb. And if electron will be having charge what? What will be the unit of electron? Coulomb. C will get cancelled. It will be 1. So n will be having no charge. C has got cancelled. So it's having no charge. Okay. This is the proof of any. This is the way how we find out the unit. Okay. If you are not knowing about the unit, just just write the formula and leave the thing alone that you want to leave that term alone that you want to find the unit of. Then just simplify it and then you will get to know about the charge. Okay, fine. Quantization of charge is done. Yeah. No. What is the question? What is that question exactly? Is equal to any one. What is the charge of an electron? No. What is the question? I'm not remembering. Safia, do you remember that thing that I told you in the very starting? No. Okay, fine. Leave. We'll now do that. That will come after this. So we'll now do what is electric current. We have known about the quantization of charge. It's given in just very short that what it will be, what the definition will be. The total charge, the total charge acquired by a body. Is it visible? Is it visible? Is it visible? The total charge acquired by a body in an integral multiple means the whole number. It should be the whole number. Fine. Integral multiple of magnitude of charge on a single electron. This principle is called quantization of charge. This will be called quantization of charge. What is the total charge acquired by a body? Okay. What will be the total charge acquired by a body? That is the quantization of charge. It will be the integral multiple of the magnitude of charge. Okay. On a single electron. Fine. On a single electron. This is about single electron. Means E. This single electron. Number of electrons. Number of charge on a single electron. It will be called what? The total charge acquired by a body. Total charge acquired by a body is an integral multiple of, this is the integral multiple of the magnitude of charge in what? Magnitude of charge on what? Magnitude of charge on a single electron. This is the single. Everything is clear with this formula. You can write the definition just by seeing this formula. Fine. Okay now? Clear now? Okay. Electric current. This is what देखो चीजें फ्लो तो करती है, मतलब इलेक्ट्रॉन्स फ्लो, इलेक्ट्रॉन्स डज फ्लो. ओके फाइन. इलेक्ट्रॉन फ्लो करता है. नाउ if electron is flowing in a particular direction, this is what I was saying ki first of all electron moves in a haphazardly way in any of the direction. It can move like this, it can move like this, it can move like this. When there are free electrons and no electricity, no battery is connected to it, fine, they move in any of the direction. They are free. They can move any of the direction. But as soon as we add on battery in this, what will happen? And switch it on. What will happen? Electron will start flowing in a particular direction. Means electron will start from here. Of course, electron will start from here, and then as soon as it will come to this side, the flow of heavy electrons will come to this side. All the electrons will rush towards the positive terminal. All the electrons will start rushing towards the positive terminal. And what will happen? And the current will start flowing in this. This is what electric current is. Electric current will start flowing from positive terminal to negative terminal. Electric current. We denote it by I. Okay. So what is electric current? What is electric current? This is what electric current is. The flow of charge. Flow of charge. Not only flow of charge, but per unit time. Per unit time. कितने टाइम में कितना चार्ज फ्लो कर रहा है, दिस इज व्हाट इलेक्ट्रिक करंट इज. ओके, दिस इज व्हाट इलेक्ट्रिक करंट is flow of charge per unit time. It must be, time must be there, because rate, when we talk about rate, if we talk about velocity, what is that? What is that? This is rate of change of distance, right? Rate of change of distance. If we talk about velocity, then what we say, this is rate of change of distance, right? And when we talk about electric current, this is rate of change, rate of flow of charges. Rate of flow of charges. Now what we need to do? We just need to flow of charge. Flow of charge is what? Coulomb. Flow of charge is Coulomb. And time is what? T. This is what we have got. The formula I is equal to Q by T. I is equal to Q by T. This is what we have got. The formula. Flow of charge per unit time. Flow of charge per unit time. Okay. If someone asks you about what is 1 ampere of current, you don't need to do anything except one thing. That is, just put 1 in front of all of them. Just put 1 in front of all of them. And just write what exactly you can see, you can figure out from this formula. What you can see is 1 ampere of current. 1 ampere of current is defined as, okay, because this is equal to, is defined as the flow of 1 coulomb of charge, because here it's 1, right? Here it's 1. Wait. One more thing, I have to write it here. I just forgot. First, we need to write one thing more. That is, the unit of current is ampere, the unit of charge is coulomb, and the unit of time is second, right? Unit of time is second. Now, when we are asked to define 1 ampere of current, then what we'll do? We'll just place 1 in front of all of their units. All of the units. This must not be. ये दिख रहा है क्या? Clear? नहीं दिख रहा होगा. 1, 1, 1. Okay? 1 ampere, 1 coulomb, 1 second. This is not capital. This is not capital. This is small. Okay. 1 ampere of current is defined as the flow of 1 coulomb of charge. The flow of 1 coulomb of charge in a conductor. Also, we have to write this. In a conductor. ऐसा ना हो कि insulator में चला गया. Insulator में तो हो ही नहीं सकता. So 1 coulomb of charge in a conductor. Okay. Per unit time. Per unit time. This is what our 1 ampere current is, because this comes in exam in one number, in 1 marks. So what is it? Define 1 ampere of current. 1 ampere of current is nothing, but it is defined as the flow of 1 coulomb of charge. This is 1 coulomb of charge in a conductor, right? In a conductor per unit time. एक second में, if means, it means that if 1 coulomb of charge is, if 1 coulomb of charge is flowing in a conductor in 1 second, then what it said to be? What is it said to be? Said to be 1 ampere of current is there in that conductor. Okay, in that circuit. Fine. Okay. And yes, now I got to remember that what I was looking for. I was looking for define 1 coulomb of charge. Define 1 coulomb of charge. So what was the first formula that we went through? It was what? Q is equal to NE. Yes or no? Q is equal to NE, right? So here it is given. Define 1 coulomb of charge. No, you can write that what will be the number of electrons in 1 coulomb of charge. This will be the exact question. 1 coulomb of charge. Now it's given that Q is equal to 1 coulomb. We are given in this formula that Q is equal to 1 coulomb. And also we are knowing about that E is equal to the magnitude of charge in 1 electron is what? 1.6 into 10 power minus 9 coulomb. Okay. We have to simplify it solve it for N. Now we have to, very simple, that we have to leave the N alone, and we have to take this E to left hand side in the denominator. So it will be Q by E. So Q is already given as 1 coulomb, and electron, we are the magnitude of electron we are already knowing, 1.6 into 10 power minus 19 coulomb. Okay, coulomb will get cancelled, so we need not to mention this. Also you can mention. So 10 into 10 power minus 19 will go to the numerator to make it positive, to make the power positive. Okay, and then what is left? Left is 1.6 in the denominator. So we can say it like we can take out, what we can do is we can take out 100 from, okay, 100 from this 10 power minus 19, so it will be 10 power 17. Okay, and then 16 will be there. So how much it will be? If we divide it by 4, so it will be 4 and it will be 25. And again, it will be, how much it will be? 6.25 into 10 power 17. Yes, it will be the 6.25 into 10 power 17. It will be the number of electrons in 1 coulomb of charge. Right? Means 1 coulomb of charge is too much. See, such an enormous number of electrons are there in 1 coulomb. 6.25 into 10 power 17. 6 into 10 power 6.25 into 10 power. I have got somewhere something. It should come out to be 6.25 into 10 power 18. Yes. Sorry. No one is interrupting me if I am doing something wrong. No one interrupts me. Huh? Rudra, can't you interrupt me if I am doing a wrong calculation? It will be 10. I have just take out. I've just taken out 110 from this 10 power 10 power 19, and 1.6 will be as it is. So if we take out this point to the right side, then 0 will come in the numerator, right? And then we will get 10 power 18, right? So this is the number of electrons which will be in what? In 1 coulomb of charge. So 1 coulomb of charge is lot. 1 coulomb of charge is lot. It will be having 6.25 into 10 power 18 number of electrons. Okay, so 1 coulomb of charge को हल्के में नहीं लेना है. It's too much. ठीक है. Direction of electric current, we are already knowing. Direction of electric current is from positive to negative. Okay, positive to negative. This is done. Electric potential. Electric potential. Now we'll solve some of the stuff here. You can solve all these examples, right? We went through these examples in the last class, right? Rudra, can you do these examples?
Yes, ma'am, I can do these.
Yes, Safia?
Yeah, I can do these examples.
Yeah, you can do these examples. And what about you, Rudra? These are the examples. Can you? Is it clearly visible? My screen is my screen clearly visible?
Yes, ma'am.
Can you do these examples first? You
Uh,
just need to put it in the formula.
Yes, ma'am, I can do.
You can do these examples, right? Just try it out, and then if you will be no if you're not able to do, then just ask me in the next class. Okay?
Yes, ma'am.
Electric potential and electric difference. Electric potential and electric difference. What is the difference between electric potential and potential difference? Electric potential, as I already told in the last class, Safia, you must have had remembered, or also not. That no worries if you don't have remembered. Electric potential is what? Electric potential is what? The work done. That is the work done in bringing a unit positive charge from infinity to the point of, to a region of electric field. Here it's electric field, right? Electric field means where the electric charges are there. So many. Okay. So it means here electricity is flowing. Here is the region of electric field, means here electricity is flowing. Okay. And the work done to bring this unit positive charge from an infinity. It doesn't mean by infinity that you are bringing from the sun. Okay, infinity means where the region of electric field stops, where there is no region of electric field. Okay, where there is no region of electric field means up to this region only electric field is there. And in bringing a unit positive charge from infinity is this also. Infinity, you can take it this also. You can take it this also, because here no electric field is there. No electric field is there. This is also this is also a region of infinity. This is also infinity. This is also infinity. This is also infinity. Okay. Taking in the work done in bringing a unit positive charge from infinity to that point. To that point means to the point of, to the region of electric field. That is called what? Electric potential. That is called electric potential. And potential difference is what? What is potential difference? It talks about in a region of electric field. This, suppose this is the region of electric field. Here are so many charges. Okay, charges are. So electric field in here in this, in bringing charge from one point to another in a region of electric field is what? Is what? The work done in bringing a charge from point A to point B in an electric field, that is called electric potential. That is called what? That is called potential difference. Means potential difference is what? Work done in bringing a charge from point A to point B is what? Work done in bringing a charge, this Q, from point A to point B is potential difference. VB minus VA. You can also say it like this, VB minus VA. See, here it is. Here it is electric potential. Electric potential at a point in a region of some charge or charges is defined as the amount of work done when a unit positive charge is moved from infinity to that point. To that point, it refers to the point of, it refers to the region of electric field. Okay. It is what? V is equal to W by Q. Fine. It is V is equal to W by Q. And electric potential difference will be what? Work done in moving a unit positive charge from one point to another in region of charges. Means electric field must be there. In region of within the electric field. Fine. Within the where there are a lot of electric charges, that region is called electric field. Okay. So that is within the region of, we are talking about, in electric potential difference, we talk about within the region of electric charges. So when we move a unit positive charge from one point to another point in a region of electric field, then that work done is called what? What? Electric potential difference. Means VB minus VA is equal to W by Q. Now we will talk about the unit for V. Unit for volt. What will be the unit of volt? Will be the unit of volt. V is equal to W by Q. The formula is saying, right? V is equal to W by Q. The formula is saying this. V is equal to W by Q. W is having the unit what? W is having unit joule, and Q is having the unit coulomb. So it will be joule per coulomb. And also we write joule per coulomb ko we also write as volt. Volt. Okay, voltage. Volt ko we write it, we denote it as V. So don't get confused by this कि V potential difference, electric potential को भी हम लोग V से denote कर रहे हैं and also volt को V से denote कर रहे हैं, तो it's okay, fine. Means if we write it like V is equal to 1 volt, we write it like this. V is equal to, if something we have to write it like in the numericals, what we will write? V is equal to 1 volt. Means electric potential will be equal to 1 volt. V is equal to 1 V. Fine. We need not to write it here like 1 volt. No. We just will write 1 V. Okay. Fine.
Yes, ma'am.
Now we'll see what is 1 volt of electric potential. Same thing. What same thing? What is defined? What is defined by what? 1 volt of electric. How can you define 1 volt of electric potential? So very simple. Just write first the formula. Write the formula. V is equal to W by Q, and write the second step. We'll write the unit. 1, is it visible? Is yellow color visible? 1 volt is equal to 1 volt is equal to 1 joule upon 1 coulomb. Okay? Just we'll write 1 in front of all of the units. 1 volt, 1 joule, 1 coulomb. Now what it signifies? Just write exactly what you can draw from this formula. Okay, 1 volt of electric potential or potential difference. Electric potential is defined as is defined as when or you can say कि 1 volt of electric potential अभी ये काट दें. Okay, when 1 joule of work, when 1 joule of work is done in bringing a unit positive, sorry, 1 coulomb of charge, not unit positive charge, bringing 1 coulomb of charge. Okay, because it's 1 coulomb of charge. 1 coulomb of charge from infinity to the region of electric field. This is the symbol of electric field. Okay, to the region of electric field. Then it is said to be 1 volt of electric potential. Okay, then it's said to be 1 volt of electric potential. Okay, 1 volt, 1 joule per coulomb, 1 joule per coulomb. Write it like this. 1 coulomb of charge from one point to another. Okay, electric potential difference between 2 points is said to be 1 volt. When it is said to be 1 volt? When, if 1 joule of work is done in moving 1 coulomb of charge from one point to other point, means it's talking about inner region of electric field. Fine, it's talking about inner region of electric field. So electric potential difference, it's talking about electric potential difference between 2 points is said to be 1 volt. Between 2 points means this point and this point, between these points is said to be 1 volt. ये कब 1 volt कहलाता है? If 1 joule of work is done, 1 joule of work is done, because here it's 1 joule in moving 1 coulomb of electric charge. Fine, it's moving 1 coulomb of electric charge from one point to another point. That is called 1 volt of electric potential difference. Okay, fine. Now we'll see examples. Examples. There are some of the smaller units of electric potential that we can write it as 1 millivolt. So milli ko we are already knowing that it's 10 power minus 3, right? It's 10 power minus 3 because you must have read in the mathematics. 10 power minus 3. And mu refers to 10 power minus 6 micro. Okay, 1 microvolt. One if we talk about larger units, then we use kilovolt and megavolt. Okay, mega को हम लोग क्या लिखते हैं 10 power 6. Fine. So these are the smaller units and these are the larger units. Okay. Now, what is the question? Calculate the potential difference between two terminals of a battery if 1 joule of work is required to transfer the charge of 20 coulomb from one terminal of the battery to the other. Okay, what is given here? Just write it. What is given. Calculate the potential difference between two terminals of a battery if we have to calculate V. Okay, we have to calculate if 100 joule of work, W is given 100 joule of work is required to transfer the charge of 20 coulomb. Okay, Q is given as 20 coulomb from one terminal of the battery to another. Now, what is V? Formula of V. Brother, tell me, formula of V. Formula for V.
IR.
W by Q, na? W by Q. This is what I'm saying last 10-15 minutes. W by Q. V is equal to W by Q. So W is given, Q is given. All we need to put the value. Okay. So V is equal to W by Q. W is what? 100. And Q is what? 20. So it will be what? 5 volt. The answer is this, 5 volt. Okay. The answer is 5 volt. Just we need to divide. Right? Now the second question reads, how much work is done in moving a charge of 2 coulomb? Okay, fine. This is the third question, right? This is the third example. And the fourth example is, how much work is done in moving a charge of 2 coulomb? So 2 coulomb is fourth. 2 coulomb is charge is given. Q is equal to 2 coulomb. And what is the another thing? 2 coulomb from a point of 118 volt to a point of 128. What is given here? V2 is given here as, see, what is given from a point of 118 volt to a point of this. Okay, means V2 is given as 128 volt. V1 is given as 118 volt. Okay, so we have to figure out first V2 minus V1 is equal to, which is what? 128 minus 118. It will be 10 volt. Means V is given as delta V. V is given as 10 volt. Delta V means difference, potential difference. This is the potential difference, right? V2 minus V1. Here 2 points are given to the electric potential of 2 points are given, so we'll divide it, we'll subtract it, and then we'll get 10 volt. Okay, and then just put it in the formula. Two things we are given, and we have to figure out for W. Just put it in the formula and tell me the answer. W will be V is equal to W by Q. So we have to know about the W is equal to VQ. Just put these values in the formula. 10 volt and 2Q. Just tell me about the answer. Okay, done.
Yes,
Sophia, what's the answer?
It's 20 joules.
20 joules. Okay, and Rudra, what about you?
20.
20 joule. Okay, so means these are very easy examples. Okay, these are very easy examples, and we'll enjoy when we'll come to Ohm's law, and then when we'll come to parallel and series combination is very interesting. Okay, parallel and series combination in this chapter is very interesting. As we'll come down and down, it will become more interesting. Ohm's law will be more interesting than the first topic, and then when we'll come to the factors on which the resistance depends, now it's very interesting. Fine. And then when we'll come to series combination and parallel combination, it's more, no any question can be more interesting rather than the question of these two. Okay, so we'll do for in the next class Ohm's law. Okay, we'll go with the Ohm's law. Fine. Okay, we'll close the class for today.